Friends, today we are going to discuss the basic item required for governing a turbine. So this is your turbine. When it is running, A is called the speed sensor. It will measure its speed, and then the signal will give to transducer where the speed corresponding to hydraulic and either hydraulic, pneumatic or electronic signal will go. And C is your speed setting device, which you are decided earlier what it should be the RPM of the turbine. It will compare with the settings, and the result difference of this will go to 4, that is amplifier. It will amplify the readings, and then finally signal will go to the actuator and servo motor, and that servo motor will operate the steam valve, and accordingly the steam going into the turbine will be controlled. Next is before going to discuss the detail about the hydraulics of steam turbine, the simple diagram and understanding is very important. Suppose this is a chamber where chamber oil is entered into the chamber B through this orifice, and oil going out through this orifice to the drain. So the chamber pressure will depends on the opening of the inlet and outlet. If you close the outlet while going to the drain, the chamber B pressure will be the inlet pressure. And if you if you open the outlet orifice, then actually the chamber pressure will vary and depends upon the ratio of outlet by inlet to outlet. That will be the chamber pressure. Next is your that is the pilot pistons. The function of the pilot piston is very important because to operate the steam valve of a turbine is very critical, because it requires a heavy force to operate the valve, because the steam valve is operating against a one side high pressure and another side low pressure. So high force is required. But this but the function of the pilot piston is it will allow pressure oil, 5 inch pressure oil is coming when everything this pressure oil is coming, five PowerPoint, and everything is normal, then nothing will go to this port. It is outlet port of from inlet oil is blocked here and here. No oil will go. But pilot piston, and this area is more. You see the servo motor area is more. So suppose this is at the bottom of the pilot piston, some secondary oil pressure will operate. This will give pressure upwards, and it will operate against a strings force. So suppose the secondary oil pressure is high, then what will happen? The pilot piston go up. When the pilot piston will go up, this port will open. Then this port will open, and this will go to the bottom side of this servo motor, and the top side of the servo motor is connected to this drain, because this is going at this drain. So the valve will open. Similarly, if you want to close the valve, what will happen? Now this will further this will push the pilot pressure. Secondary oil pressure is low, then pilot piston will move through the spring force, above spring force against the secondary oil pressure, and then this will close here, and oil will go to the top portion of the pilot servo motor, and bottom portion of the servo motor is where it will going to connect to the drain. Uh, Connect to drain, and this will close the valve. Like this, the valve is open and closed depending upon the secondary oil pressure. And this area is more. That's why the power required for operating the valve will be steam valve will be more pressure will be more force will be available. Now, there is a pilot valve. You see, this is the pilot valve. This is connected at the bottom of it, the secondary oil pressure. At the top, it will be balanced against the spring force. This is the pilot, and this is the servo motor. Suppose you want to secondary oil pressure is high. When secondary oil pressure is high, it will go up, and and this oil will come. This port will open, this port will close. So oil will go from this port to the bottom of the servo motor, and it will push this piston up. When they put this piston up, this is the fulcrum. So this will up and this will down. Again, this will push the piston in the center position. So the servo motor will take the new position. Suppose your this pressure is less, then this will due to spring force it will come down. When this will come down, oil will go to the top of the servo motor, and bottom will connect it to the drain, and then the bottom will connect it to the bottom. This bottom will connect it to the drain, and when this drain, this due to high pressure it will come down. When this will come down, due to this fulcrum, this will go up and again bring the pilot piston in the center position. So no oil will go at the top and the bottom, and the servo motor will take its new position. This is the principle. This way the servo motor is working. Now, now I'll tell you the distance of this spring to the pilot piston here. So very high movement of the servo motor is required to get the spring force here to this to high movement, high lift is required to get the minimum movement of the pilot piston. That's why it is called the lower regulation. For higher movement, the pilot piston will move down, so valve will open more and close to bring this pilot piston in center position. That's why it is called a lower regulation. And higher regulation will how much? Now when the distance from here to here is less, so small movement of the servo motor, this valve will come to center position. The pilot piston will come to the center position and stop the oil flowing. So that is called higher regulation, because it is for small movement, pilot piston movement you are getting very fast. That's why it is called higher regulation. This same regulation can be done instead of these two distance. Instead of these two distance, it is normally cannot be changed because pilot piston position is fixed. So you cannot change, and this position is also fixed, so you cannot change. So what we are doing, we instead of this distance, varying the distance, we are mounting a cam here. When we are mounting a cam here, when this valve will come up, this is the fulcrum. This is the ball. This one is called your. It is item number 12. Number 12, bell crank followers. Bell crank follower. Bell crank follower. Bell crank follower is are constant touch with this cam. So this small angle of this cam, the ball crank follower movement will be very high when the angle is less. So this is called the higher regulation. If the angle is more, then for small movement, this you will get the pilot piston movement center position. You will get center position. That is called higher regulation. So instead of moving this, varying the distance here, which is not possible in running case, we can adjust the angle of the cam by the screw so that higher and lower regulation can be achieved. Now I will discuss the simple hydraulics. What I have told you, that simple from the second and tip oil lines, some tip oil will come, and through this orifice it will go to inside. It will go to the inside of the. This is called the follower piston. You see, this is the follower piston. This is the follower piston. This is mounted against the spring at the top. This you can adjust the stiffness of the spring by the screw. When oil will go inside, normal cases, this is the slip is this follow-up piston having the hole, and the slip is moving up and down through governor, that also having a hole. When you are on the slip, when you block this hole, pressure will build up and the spring will extend, and then again the oil will the follow-up piston will come in the steady state condition. And steady state condition, these will just overlap. Minor oil leakages will be there. So and accordingly the secondary oil pressure will develop. Secondary oil pressure will develop. Suppose you secondary oil pressure will develop. This is the hydrodynamic governing system. Here, primary oil pump from the as per the RPM of this turbine, the pressure will develop, and that oil pressure will develop, and oil pressure will act on the bellow, above the bellow, and this will push this piston upward and downward against the spring force, and this is mounted with the sleeve. And if you want to increase the RPM, you just increase the stiffness of the spring. And then this sleeve will move down. When this sleeve will move down, some oil it will close this port. Then the spring oil force above inside this follow-up piston will increase. It will move this piston downward against the spring force, and your secondary oil pressure will increase. So the oil pressure will increase, increase. So according to your, you can change the setting of the spider spring, and accordingly the sleeve position will be changed, and your secondary oil pressure will change. And when the secondary oil pressure will change, I have seen you how it will go to the servo motor, and accordingly the speed of the turbine can be governed through servo piston and steam throttle valve. For increasing the speed, this is the steady state condition. At this condition, the two holes are just simply closing. Minor oil leakage is there. Minor leak of oil leakage is there. Suppose you want to increase the speed, what we'll do? We'll close this. You will just close this valve by X1. When you X1 close, then this oil going inside, or this oil going inside will pressurize this pilot piston spring and bring it down to show that the steady state condition achieved. And as the spring is stretched, so oil pressure will increase, and secondary oil pressure is also going to increase. And that will increase this pilot piston pressure, and when the pilot piston pressure is increased, the steam valve will open. And similarly, for decreasing the oil pressure, you just open it further, down the sleeve, downwards. More oil leakages will be there. So what will happen? The pilot piston will try to move upwards, so that the pilot piston will close this hole just in floating condition. So secondary, as the spring tension is released, so secondary oil pressure will also released, and your valve will close. Like this, you can adjust the RPM of the turbine. Now, if you move this sleeve up and down, then what will happen? Your HP and LP, both the crossover HP valve, only if it is only HP valve, direct condensing, then your HP valve will close and open. Accordingly, your RPM, steam flow to the turbine, will go on increasing and decreasing. But suppose you are using an extraction, then you need more extraction. Then instead of this governor is now fixed position, RPM is fixed, so governor is now act as a fulcrum. There is the actuator. This actuator will operate this lever. The actuator, this is the actuator, pneumatic actuator, where the pneumatic signal will come according to your pressure, according to your extraction pressure. If you want more extraction pressure, then this valve will go. This valve will go on. This pilot piston, this pneumatic actuator will move the piston up, move this lever upward. When this move this lever upward, this valve will open. The main valve going to steam turbine open, but it is fulcrum, so it will go down. Extraction will close. Extraction valve will close, so you will get more steam extraction. Downstream, after extraction, less steam will go to the condenser. If you want less extraction, then what will happen? It will move the lever downward. When you will move this lever downward, this valve will close. When main steam entry to the turbine will close, and this will open. Extraction valve, turbine internal extraction valve will open. So more steam will go to the condenser. Extraction will get the less extraction. So this is the two way two-way. If you with pneumatic actuator you can control the extraction, and with the governor you can control the extraction by closing and opening, by closing the HP valve and opening the LP valve, or closing the LP valve, opening the HP valve, HP valve. You can control the extraction, or with this governor, then the actuator will act as a fulcrum, and if you open it, both HP and LP will open. You close it, both HP and LP will close. This is the principle by which the extraction as well as the load of the turbine, or indirectly the RPM of the turbine, can be controlled through governor. Now the tipping point. What is the tipping point? The spring is there is a, when suppose there is a gap of point when you are overlapping, when you are increasing the piston, the follow up sleeve upward, then more oil will drain. So what we are doing, we are moving more oil will drain. So what will happen? This will move upward. This will move upward and close it. But and again you are pushing this downward, so again the oil will drain, then again this will move up and close it. Like this, the follow-up piston will move upwards. But once the secondary, when the secondary oil pressure is 0.2 and something like that, it will stop here. This is called stopper. It will stop here. If you further reduce the overlapping, this will not go up. This follow-up piston will not go up. Instead of going up, the spring will lock here, and suddenly, as it is not going up, all oil will drain, and when the all secondary oil drain, your HP and LP valve will close, and with a high or low oil pressure and along with the spring pressure, both these HP and LP crossover valve, HP valve will close. That's why it is called the cutoff pressure. If you gradually close it, so it will not close suddenly. So it is required to be closed suddenly with hydraulic pressure. So that's why after 0.2 or 0.3 something, maybe that's called cutoff pressure. If you further reduce it, oil pressure further reduced, secondary oil pressure further reduced, but turbine will close all of a sudden. That will ensure that valve turbine is under shutdown. Now the pilot piston, which is moving inside the sleeve, if it is running continuously at the same RPM, there is a chance that it may got stuck up. So that it should not get stuck up, what we are doing, we are allowing some pressure oil. You see that from here we are doing some pressure oil, tapping is there from inside. Some oil we are through this sleeve, we are putting the oil into this through this hole into this pilot piston, into this control slides. When this control oil will come, is bottom there is a close, but in the top there is a disc. You see the disc, there is a whole annular space is there. You see the annular space is there, annular space is there, annular space is there, through which the pressure oil will go tangentially, and due to jet action, this is go on moving. It is go on moving, rotating RPM. It will rotate. When this is rotated, there is no chance of it is going stuck up. Not only that, the secondary oil is also acting on the bottom against the spring force here, So there is a bearing is also there, because this one is rotating. But this oil, when secondary oil will come, there is a slip, there is a hole, and the pilot piston, there is a hole. When it is rotating, one time will come. Then when this hole and the sleeve hole will match each other, then certainly some water, some oil will come inside, and it will move this pilot piston. Slightly fluctuation movement will be there. So momentarily oil will come, then it will going to drain. Again momentarily oil will come, it will connect with the hole. Momentary oil will come and it will going to drain. So this will go on fluctuating like this. It is a reciprocating motion plus circular motion due to this jet action, and then there is no question of getting stuck up. But once it gets stuck up, during stuck up, valve will not operate. Then you have to take this valve, take the top cover open, take the pilot piston open, and see whether any foreign particle has come and blocked this hole or passage or not. Once it is blocked, you have to clear it through air and oil or paraffin, and then you can box it up and see whether this is the tachometer is there, whether it is rotating or not. Now, Which I have till now I have told you the hydrodynamic system, hydrodynamic governing system. In hydrodynamic governing system, I have told you that the drawing here the turbine oil pump is there that is rotating to the turbine RPM. This oil pressure will RPM is more, then oil pressure will certainly will be more, and that oil pressure will act on this bellow, and this is push this bellow upward and downward as per the RPM of the turbine, and this will acting against the spider spring, and accordingly your setting, if it is setting pressure, if it is more than the setting RPM, then this will move up, this will move this slip up and down as per requirement, and your draining will take place. Follow up piston, the secondary oil pressure will develop, and it will accordingly close the HPLP throttle valve, or alternatively, if you want to get more extraction, then through this pneumatic valve you can do that. But this is the hydrodynamic governing, and now I am talking about the mechanical governing. This is the mechanical governing, where you see the woodward governor is there. When this is the governor is run by the turbine speed. When turbine load is high, that means speed is low. When speed is low, this RPM also of the governor will be low due to the low. This is the flyover. Flyover, it is pivoted here. It is acting against this spring force, so this will come inside. Low RPM, it will come. Speed is low, that will come low inside. When it is low inside, due to spring force, this pilot piston will go downwards. Pilot piston will go downward. When pilot piston will go downward, some more oil will come and move the servo motor upward. When move the servo motor upward, then it is fulcrum here. It will go again up. When this one again up, this will come center position, block this oil, and the servo motor will take its new position. When the load is less, then RPM of the turbine will high. When the RPM of turbine high, this will fly outside. This will fly outside. This will move this pilot piston upward. When move the pilot piston upward, some oil will drain, and this will move this steam valve downward, and when move the steam or the servo motor downward or steam valve downward, then again what will happen? This will push this pilot piston downward. Again, this will block the oil flow. It will upward, push it down, so it will again block this oil and arrest the drain from this to this. So accordingly, the servo power piston will take the new position. Now, I have told you this is the starting device. I have explained when the starting device. This is the final position of the different port will come from the starting, and the final position oil will go to the steeper will go to the ESV, emergency stop valve, upside. And it will open the valve with spring in compressed condition, and downstream oil will go, and it will be connected here and going to drain. It is going to drain. This is the final position. You have to lock it this position, so this will act as a fulcrum. This will act as a fulcrum. And when you are woodward governor or a governor operating this lever will go up and down. When you lever move up and down, both will open or both will close, and accordingly your RPM will increase or RPM will decrease. But if you want, when your governor is fixed, when RPM is fixed, then this will act as a fulcrum. This will act as a pivot point. This will act as a pivot point, and this one this pneumatic control valve, pneumatic actuator, this will operate this lever against this spring force. This will move up, and this is the fulcrum here, so this valve will go down. This follow piston will move up. Accordingly, this pressure will reduce, this pressure will increase, and once that means your control valve will close, HP control valve will close, and LP crossover valve will open. We will get less extraction and less is load. When you want to get the more extraction, what will happen? We will bring it down. When you bring it down, this will go up. This will close the valve. This will LP valve. This will close, open this LP valve. So main steam entry to the turbine will increase, and turbine going to the condenser will decrease. So you will get more extraction. This is the system, schematic system. This secondary oil line going to the pilot piston, then servo motor. This is the HP valve, and this is the LP valve. This will close this turbine extraction valve close, so you are getting less or more extraction and by this control by this actuator. This is moved down, this is more up, so valve will open, this valve will close, you will get more extraction, you will get more steam is coming to turbine, this is closed, so you will get more extraction, and you want to get less extraction, you move it downwards, so what will happen, this will go up, when this will go up, this will close and this will down, this will close and this is down, this will up, so this will open this valve, so this is steam entry to the main turbine will close, steam going to downstream is open, it is going to condenser, so you will get less extraction. This is the uh, principle by which the turbine governing system is working through hydromechanical, hydrodynamic, hydraulically. So I have tell you the essential parts of a governing system, how it works. I think if you go through each and every slides, your concept will be clear. But still, if you have any doubt, you can ask me in my mobile number or email ID. I think I will certainly try to clear your doubts, and there may be some question may be asked. SR4 governor is a hydrodynamic governor, mechanical governor is woodwork governor, then the feedback system, everything is there. So by speed governor, you can either increase the load or decrease the load, increase the RPM or decrease the RPM. By extraction control actuator, you can either increase or decrease the extraction.